Hello, I'm Ralph Ferguson, Managing Director of the Texas Tech University Ethics Center. And today we're going to be visiting with a global scholar to discuss his objectives and plans that he has related to research. This particular scholar has special meaning to the Ethics Center because Bill also serves on our advisory council and has been very helpful in developing our programs across campus and across disciplines. So let him introduce himself.
So my name is Bill Poirier. I'm a professor in the Department of Chemistry and Biochemistry, also joint appointment in physics, also the graduate program director for the department and on the graduate council for Texas Tech and the Ethics.
Well, and Bill, I want you to know you've done a wonderful job for the university with working with students, and I know you've done a wonderful job for us here in the Ethics Center.
Thank you.
And the reason we're talking today is it's very important to appreciate global scholars, because one of the things that global scholars demonstrate is, one is they have high ethical value, and the other is they have a qualification or reputation that stands above the rest. And today we want to talk with Bill about a very, very special thing that has happened to him, and that is that he has been awarded a fellowship from the Hungarian Academy of Sciences. And what we want to do is have him talk to us a little bit about that, working on the other side of the ocean to discuss science and science needs. So can you kind of fill us in on what's happening?
Sure, absolutely. So one of the aspects about doing global work, as it were, is that you can't know everybody in the world. And in fact, the people who invited me, I knew them by reputation, but we weren't personal friends or anything like this. Actually, one of the main person I'd never met before. So he just invited me based on the strength of my work and my papers and so forth.
Outstanding.
As opposed to being my personal friend or the reputation of the school or something like this. It was just purely based on the science. So this program, it is a very special program. I wish we had something like it here. It's a Hungarian Academy of Sciences Distinguished Guest Scientist Program. So it's across all the sciences, so broadly defined, including social sciences and so forth. Every year they invite, I think it's 4 people. If you do the math and look at the total annual budget for the country and look at what I'm getting, it's 1/4. So I'm guessing from that they invite 4 people each year. Like I said, across all the areas of sciences. And you have to get, to be nominated for it, you basically need 2 people to nominate you. One of them needs to be from a top Hungarian university, and the other one needs to have a connection with the Hungarian Academy of Sciences. Okay. So the second person is someone actually I have known for some time, but he was not the main person pushing this, but he did sort of sign his name.
Of course.
And so we put the application in last year, or we talked about it last year. I guess the application was not due until early part of spring of this year. Found out in May, and I'm heading over in January for 6 months.
Let me ask, what exactly, as a scientist, you're going to be doing with the Hungarian scientists, and what exactly do you see as being the benefit coming from this partnership?
Okay, so you want to get into the technical details already?
Yes.
Okay, sure, happy to. So there are several parts to this, and some of it is technical, but some of it is broader also. And of course, in the back of my mind, I'm always thinking, how is this going to benefit Texas Tech? I'm thinking again with my graduate activities, students. How do we get students from there to come here? So this is, for me, a part of the motivation for heading over there. But officially what this is about is a project that's going to make it possible to use quantum mechanics to study big molecules that are important in chemistry and physics and various other fields. So what is quantum mechanics? Well, quantum mechanics is a very difficult area of science that unfortunately is, or fortunately, depending on your point of view, is the way the world works at the nanoscale.
Okay.
So you can't really ignore it if you want to get right answers. However, because it is so difficult, people traditionally do ignore it. So what they do in practice most of the time is they treat molecules and atoms and things like this as if they were little billiard balls or classical objects that move according to Newton's classical laws. And that works okay for certain things, but if you want to get the right answer, you have to use quantum mechanics, and this is hard. So there are a number of people who are doing this. That part's not so unique. My contribution to this field, or one of my contributions, is to find a way to do quantum mechanics on big parallel computers.
Okay.
So one of the very special things we have here at Texas Tech is very nice computer resources, both on campus and also access to an even larger facility housed at University of Texas. And this is something that they don't have in other places in the country, let alone in other countries. And so from their perspective, what they're going to learn is how to use cutting-edge computer equipment.
Okay.
Right, so this is one aspect of what I'm doing while I'm over there. Of course, there's the scientific research itself, right? We're trying to develop these techniques using some computer codes that my colleagues have developed over there, but combined with my own codes that can handle what we call massively parallel computers. So that's the main scientific purpose. But the broader purpose really is to get these Hungarian students and postdocs and researchers who are very excellent. They have very, very good academic training, to get them to use these modern computer facilities. And conversely, from our end, it's to hopefully set up a pipeline to get these wonderful students coming to Texas Tech.
In doing your research, for a layperson, is there an outcome in the research that you're doing that will benefit those of us that have to use a computer on a daily basis? Will it enrich that process down the line?
That's a good question. It might. That's, I would say, probably not the immediate goal. But the fact is that if you can do simulations at the nanoscale more accurately, then many good things will follow.
Okay.
Right? So one of the things you might be simulating, for example, is a computer chip or something like this. And so in that sense, it might lead to better computers if that's what you're asking.
Yeah.
But it could also lead to better drugs.
Time that you'll spend in Hungary, will it be a year, 6 months? How is it?
So it'll be 6 months. The program allows me to go for anywhere from 3 months to 12 months. But the decision is made in May and all the money has to be spent by the following June. So realistically, I'm not going to pack up my bags and leave the next week after I hear the decision, right? So 6 months seemed like a good compromise, long enough to get stuff done, but not so long that I'm letting things fall apart back here in Lubbock.
Right. And given you do the program for 6 months and you work with some students, when would you anticipate maybe having some of the students from Hungary come here, or maybe some of our students go there? Has that planning been put in place?
Well, that's a little bit down the road, a year or two. I mean, I think the first thing, so Texas Tech, as you know, is very interested in international outreach these days, and I think that's very good and very important. And of course, we're always talking also about graduate students and getting more international students from different countries. But really the best way to make that happen is you have to establish connections among faculty first. So that's the first step, and by spending time there, getting to know their needs, the individual members of their group and so forth, spreading West Texas stories, that kind of thing. Hopefully that will lead, in time. Hard to predict exactly, but I'm thinking maybe a couple of years, something like this. I've since written a new book.
Okay.
It's not out yet. It's going to be published through Springer. There are 3 authors. The other 2 are University of California authors. One is from UC Berkeley, the other is from UC Davis. And this is a book that's a bit more for lay audience as opposed to a textbook.
Okay.
And the purpose of this book is to lay to rest misconceptions in modern physics. So my part deals with quantum mechanics, which, as I mentioned, is the subject of my research. So a part of this Hungary trip, anyway, is outreach with respect to quantum mechanics for sort of a more general audience. So I'll be giving public lectures, this kind of thing, as wearing that kind of public outreach hat as a part of this. And that was in our original proposal, and it was something that the Academy found appealing.
Well, I know that from the Ethics Center and also from the university, this has got to be an outstanding opportunity for one of our professors. And definitely, I know from knowing your character, an outstanding opportunity for the Hungarians to have you over there, even if it's just for 6 months, because you're a very talented guy, and I suspect that in the long run, this will take and support our agenda to be a global institution, and at the same time, cultivate a great deal of new knowledge that will benefit technology for us across the board.
I'm certainly hoping that's the case.
All right, Bill, thank you very much.